this is a wonderful opportunity for me. I've just finished 3 papers trying to estimate for myself the things that absolutely amaze me about what people call AI. So I hope you're 1/4 or maybe 25% as interested as I am, or you will be after this talk. So far today, many people have talked about the applications of AI, whether it's for aiding some, curing a disease or something like that. I'm going to talk about what AI is. I'm going to talk about the philosophy of it, the limits and the power of it, but I'm going to restrict my comments to what I call AI-based data science, and I'll explain that in a little bit. As there are no question and answer sessions here, I am sure you're going to have questions. I would be delighted to answer a question, so send me an email, telling me just who you are, or what your areas of interest are, and ask your question, and I will endeavor to answer as many as I can. So this talk is going to be about what I call AI-based data science. It's unfathomed. Unfathomed means that it is greater than anything we've ever seen, and we haven't yet reached the limits of scope, scale, complexity, realism, and flexibility and power. In fact, what I'm going to say later on and try to explain is that AI-based data science is more powerful than science. So one of the interesting challenges that makes this AI-based data science challenging is that it's inscrutable. So I've been in the field for the whole duration that field has existed. And we who create, use, and deploy these solutions, we have no idea how they work. We have no theory underlying it, which means we cannot prove that a result from it is accurate, correct, and I'll get on with more of those things. What we in the field have seen and fully believe is that this technology will transform every data-rich discipline, task, and profession in the entire world. And we are just at the beginning of what is being called the AI revolution. So ChatGPT, which you've heard a lot about today and probably everybody here has used, it was launched in November of 1922, and unlike any other previous piece of software, it gained 1 million users in 5 days. 1 year later, Threads was launched, a similar chatbot, and it got 1 million users in 1 day. That just shows the world's attention, because this isn't accessed by scientists. This is accessed by people like you and I, just people who are experimenting with what is this crazy stuff. So, generative AI is a portion of AI-based data science. There are 2 main ones, and I'm sure you're familiar with them. The first one is called large language models, and it is using deep neural networks to do language recognition and generation. Recognition means it understands what you speak, and generation means it can generate an answer to a question you pose. ChatGPT has had 14 billion visits in the first year. So that's a pretty commonly experienced phenomenon. The second one is convolutional neural networks, which is used for image recognition and generation. I'm sure you've all used it to have the machine generate funny diagrams. Almost every picture used in this talk has come from convolutional neural networks. And it's popular, but obviously not as popular as the large language models. So the applications that you probably use, ChatGPT, it's at the upper level of the stack. That rests on models. I'll tell you about how you create those models. And those models run on the cloud, and the cloud runs on very specific types of hardware called graphics processor units, GPUs. So you can see there's a wide range of companies that are involved, but it's a really small number of companies. And like the former speaker, as the philosopher said, that the power of AI is in the hands of a very small number of companies. So you probably already know governments don't run the world, billionaires run the world. And the billionaires own this stuff. And so that should be a cause of alarm. It's not a technical alarm. It's a moral, social, and political concern. So you've heard the term neural networks and deep neural networks. They are, the artificial neural networks are the way in which this AI is executing. They are inspired by the brain. So brain scientists know how the brain works at a low level. That is, the brain has billions of neurons that are interconnected in complex ways they don't fully understand. And there's an input layer called dendrites. It gets signals from other neurons. It does some processing in the nucleus, and the result of that processing, it sends out results to other neurons through the synapses. So it's brain-inspired, and a little later I'll tell you, we actually don't know how the brain works, but they have inspired this architecture. This architecture is the way in which AI programs are structured. They are neurons, and they get inputs from other neurons. They give outputs to other neurons. They're deeply connected. And so a neural network like this that is trained to recognize pizzas, it'll get a pizza as input, an image of a pizza as input on the first input layer. That input layer will transform what is a picture that you and I would recognize visually. It will translate it into numbers because all the processing is done on numbers. It goes to intermediate layers, and each level beyond the input does a different kind of processing. In simple terms, when you recognize an image, first of all, you see the pixel, the dots that make up an image on a printed page, and the next one may see lines, and the next line may see shapes, and so a shape may be a piece of pepperoni on the pizza. And at the end, the output, it says, oh, this image is a pizza. To what extent does the neural network know the concept pizza? It does not know it at all. The neural network was trained, but before training, I will say, neural networks are programmed by humans. They're programmed by humans to do various tasks, like classification, association, regression. Classification would say it's going to take everything that looks like a pepperoni and put it in the circle of things like that. And it's going to get pieces of mozzarella, and it's going to recognize everything that looks like mozzarella. So that's classification. And it puts the classes together, and it says, this is, and where does it get the name pizza from? It gets it from labeled inputs. So the network is trained on, let's say, 10,000 or 100,000 images of pizza. And as each image goes through in the training process, it impacts what each neuron does. Each neuron changes what it computes by what are called weights and biases for measures. Biases. That's where we get to what we don't know what it does. When it learns from seeing 100,000 images of pizza, we have no idea what's going on. And then at the end, when it says it out, so it doesn't know the concept of pizza, but it was told that all of those 100,000 images it saw are called pizzas. So when you see something like this, tell me it's a pizza. That's the extent to which the neural network understands human concepts. It doesn't. So to look again at what is AI-based data science, it is learning from data. More precisely, you're discovering knowledge that is represented in the data by some sort of complex computation structured by the neural network that I just shown you. And it's inaccurately called AI. What's AI? AI is a technology that enables machines, algorithms, or computers to do things that you would expect the humans to do. Speak, recognize, interact, and of course the robots are walking around. That's not what generative AI is about. Generative AI is about things that I'm going to be talking about now, like language recognition and image recognition. So AI, the general definition I just gave you, consists of about 50 areas. Only about 10 of those areas relate to all the AI you've been hearing about. So, okay, robots are interesting, valuable, and all that sort of thing, but they are not what has caught the world's attention. Mind you, AI robots are now using AI-based data science in order to improve their language recognition and generation, as well as image recognition generation. And the rest of the areas within AI are not, sorry, did I say the topics that are specific to AI-based data science, the stuff that the world is talking about, is only about 10 areas. Deep learning, reinforcement learning, semi-supervised learning, there's a few things. And that's the core technology. And then all of the other areas of AI are typically applications of those core technologies. So when I use AI here, and when many of the speakers were using AI during earlier talks today, they typically refer to this rather narrow area, powerful area, of AI, what I call AI-based data science. So AI-based data science is a novel paradigm. Novel meaning the first neural networks were invented in 1943, but they had no power. It wasn't until about 1986 that they really got a lot of power, when Jeff Hinton from the University of Toronto added about 3 or 4 really major advances, which is, you saw the neural net that I showed you, the artificial neural net. It looked like it was one layer. Well, in 1943, it was one layer. But Jeff Hinton, he added many layers. So they're very broad. Compared to the picture I showed you, they are now very broad, very deep, and very tall. And they can be extremely large and complex. So he added depth. That's why they're called deep neural networks. GPUs for fancy processing, massive amounts of data so that the network could learn. And he had to introduce an entirely new learning mechanism called backpropagation, so this multi-layered thing can be learned. Now, you don't need to know all of those technologies that I mentioned, but just to show you that it's a novel technique and it's been evolving only fundamentally for the last 20 years in any really powerful way. And what's amazing is every single day there's some advance that comes along. So the philosophy of AI-based data science is learning from data. And I'm sorry to be tedious about this, but it is the use of complex analytical methods, those neural networks I told you about, to conduct some sort of computational analysis. And we don't even know what that computational analysis actually does until we see the results of it and say, oh yeah, that's right. That is an image of the pizza. And it discovers what we call knowledge. And nobody knows what knowledge is. But it discovers knowledge in the patterns in the massive data sets that it analyzes. So it's maybe worth the need to know, but it's not simple. And AI-based data science is data-centric. If the knowledge you're trying to discover or the problem you're trying to solve isn't in the data, you're not going to get what you want. So it is data-centric, and tomorrow I will talk a bit more about it. So earlier today we heard many people mention AI. Not a single one mentioned the data that would be used for any of the applications. So imagine this. you have what's called a training set. You have this bare neural network that a human coded to do association for neural networks for image recognition. And so what you've got to do in order to train it to recognize a pizza is you've got to get enough data that represents all of the characteristics that you know are definitive for a pizza, and that's got to be in the training set. And if it's not in the training set, the neural network is not going to learn what a pizza is adequately. So choosing the right data is absolutely critical, not only for the training set, but the inference set. What's the inference set? The inference set is, oh, here's 20 pictures. Tell me which ones are pizzas. So it used pizzas to train it, and then it now can solve the problem, is this a pizza or not? So it's equally important to know what data science is not. So last Thursday, we had a meeting at MIT with roughly 200 of the world's leading AIers, brain scientists, and neurologists. And the question that we posed to the meeting was, are large language models intelligent? And I'm pretty sure almost everybody here who's used ChatGPT thinks it's intelligent. Well, for starters, we don't know what human intelligence is. So when you say it processes like humans, you have an intuition of what it means to reason or to solve a problem or to remember. You intuitively know what that means. And the ChatGPT seems to do all that. So it must be human-like, right? Well, we actually don't know how the human brain works. We know at the neural level, and we know that different areas of the brain are responsible for certain functions or actions or thoughts, but connecting the two, we don't know how that works yet. So it seems reasonable to say it's brain-inspired, except we don't know how the brain works. So the conclusion at the meeting at MIT, these experts, I'm not a brain expert at all, I'm just recording what they said, is these neural networks don't have an understanding like humans in any sense. And artificial neural networks, like chatbots, are less intelligent. And intelligent is a metric, which is, do they have certain capabilities? And there are a lot of benchmarks to test chatbots to determine the quantity and the speed with which they can answer questions correctly. So that's what the intelligence means there. But that intelligence is not like humans. Why? Because every chatbot knows more than everybody in this room combined. And they know it instantaneously. Why? ChatGPT was trained on the entire web plus other corpuses, other libraries of books. And so you will never read all those, so you never know what's in them. So the lesson when you're using an AI tool, no matter how well you're prepared it is, you have to assume that it doesn't understand human concepts like pizzas or pies or my hand or anything like that. On the other hand, since it doesn't understand human concepts, presumably it can find patterns that correspond to concepts that humans had never ever thought of before. So that's really cool. Humans, in order to make these systems work in what appears to be a sensible way and give a reasonable answer, is they have engineering techniques that try to force the chatbot or other AI solutions to reason like a human. So that's okay, meaning if you can prove that it thinks like a human when it's trying to solve a molecular physics problem, that's good because it corresponds to what you know. But you're not going to learn anything beyond that, and you may weaken the power of the neural network. And so what is absolutely striking is we don't know how it works, we don't know how to interpret it, but at the same time, engineering techniques are so good that these systems, some of them, work far better than human beings, and I'll give you a couple of examples in a minute or two. But finally, it is not what is called artificial general intelligence, which is also called human-level intelligence, which means, and that is a term that was invented, 20 years ago, and it says AI will be intelligent or will have artificial general intelligence when such a tool can perform better than human beings on most tasks, and better often means 8%. So ChatGPT, which you've all heard about, it can write a book, it can code algorithms, it can pass the bar exam, it can pass the U.S. certificate for medicine for a doctor. So it's incredibly powerful. Now let me see if I can remember the statistics here. Do I have them down? For GPT-3, it cost $100 million to train. Why did it cost $100 million? Well, they trained it on the entire web, so that took a lot of computation. But in order to speed it up, the technique that OpenAI had was they used the most powerful chip in the world produced by NVIDIA. It's called the GPU, graphics processor chip. Why is it powerful? It has billions of transistors that chip can do parallel processing. So when you're looking at an image, you can parallel process the entire image on a single chip in moments. Now, that chip that they used for GPT-3 training they used 10 to 20,000 such chips. It's not announced formally how much they did because it's a company secret. Those chips cost between $10,000 and $15,000. 15,000 chips times $15,000. Pretty soon you're talking about real money. So that's why this stuff is expensive, and it imposes all sorts of problems. This next story is a wonderful one, and it is an example of how AI can solve problems that humans have tried to solve for generations. And not only is it amazing that it has a solution, but the solution is detecting cancer, brain cancer, lung cancer, skin cancer, and others. But this one from Google does brain cancer. So not only does this tool that generated by Google, not only does it detect cancer better than a surgeon or a radiologist who are professionals at this, it can detect cancer about to emerge years before it emerges. Meaning to say, in the case of cancer, since we can't solve cancer, if you can detect that cancer is going to be coming in the next 3 or 4 years, you can have an operation and presumably get rid of it. So that's a phenomenal thing that it's done. This is only one of many examples of the positive ways that AI can improve the world. This next one is even more amazing as it gets going. This is an image for a product produced by Google DeepMind called AlphaFold. For about 15 years, man has tried to discover the three-dimensional structure of a protein. That's important because the three-dimensional structure permits the protein to carry various ingredients. I don't know what they are. I'm not a biologist. And those ingredients cause it to be a vaccine or causes it to be able to cure various parts of the body. So that in designing drugs for curing various diseases, this tool, so did I say that it took, for protein folding, it takes something like 5 to 10 years. It normally a PhD plus a bunch of other students, a professor advising it. So it was a team of people for about 5 to 10 years in order to do protein folding before AI. This thing solves protein folding in 4 hours. Actually, that's not exactly right. Remember I said you can't prove the results? And because this is so important in medicine, what they do is they run AlphaFold for the particular protein they're looking at. And it runs for 4 or 5 hours on a very powerful machine. And they run it 5 or 6 times. So let's say 30 to 40 hours. So 40 hours kind of beats 5 years and 10 people. So that's an amazing result. Another amazing result, because of the number of lives that was saved as a result, is the creation of vaccines. In about 2011, 2012, there was a SARS and MERS pandemic in Asia. And the company, Moderna, from Cambridge, Massachusetts, where I live, they started developing an AI-based tool for designing vaccines, similar to AlphaFold, they didn't use AlphaFold, but things like it, to determine a recipe, shall we say, for drugs. And the way this happened is when the SARS-CoV-2 broke out, apparently in a lab in China, one of the scientists who worked closely related, at least geographically, I don't know if she was in the lab or not, he sequenced the virus, put it on the web, and let's have a guessing game here. When Moderna got the genetic sequence and they applied it on their platform, how long do you think it took to get the vaccine that was used worldwide called Spikevax? How long do you think it took? Just yell it out? 40? Oh, you read the paper. Oh, you did? 48 hours. They downloaded it. They had to determine. So what they actually did was, you see those red things, those are called spikes. And so you don't want to insert the virus into a human. So what they did is they took the genetic sequence of the spike, and when the body sees the spike, it says, oh, this is a foreign thing, I'm going to react to it and I'm going to kill it off, and raise the body's potential to stop this. So it was extremely safe. By the way, it was also safe because it was a methodology with which information was used to build the body's resistance, as opposed to the olden days when they used to give a little bit of the virus to improve it. So it's much safer. I'm wasting time here. So I'm about to show you an example of how AI will change every data-rich job, discipline, and career. Every. And you'll see why, I think, by this one example. We are just at the beginning of this revolution. I'll talk about revolutions a little later. The ones you're most familiar with have lasted 200 or 400 years. This one, we don't know how long it'll go, but it's fair to say it may take a century. And we're just beginning to see what can be done with it. I will talk at the end of the talk, if I get there, if I have time left, to tell you why it is so much more powerful than science. And tomorrow in my talk, I will tell you why we don't understand it, what aspects we don't understand. Job losses. So when a new technology is introduced that can replace, let's say, manpower or some other technique, and what happens is the tasks that require more education, more skill, there's a ladder of low level, mid-level, and let's say doctors or scientists up the top. So what happens is that technology, the new technology takes jobs away from the bottom. Interesting technologies, and I'll mention this a little later, they add new jobs at the top. So AI will replace more jobs than any previous technology has ever done. Consider coding and software engineering. So Microsoft has a product called Copilot, which has been generating software for like 3 or 4 years, I would think. They don't like to disclose, most companies don't like to disclose exactly how they're using AI, because their competitors will try to do the same thing. So Microsoft announces that 35 to 75% of the coding that is at Microsoft, and do they do anything else other than coding? I mean, that's their main thing, is AI generated. The answer from people inside Microsoft, who I know well, 80%. The answer is really 80% down. There's a guy in Silicon Valley, Matt Welch, who has a company that produces a coding tool. He did the following really interesting study. In 2023, 1 hour's cost of a Silicon Valley programmer was $1,200. Did I say 1 hour? I meant 1 day. 1 day costs $1,200. With his tool, it costs 12 cents. So that should convince you that any data-rich application can be changed simply by the force of economics. Why would anybody pay programmers $1,200 when all they need to do is pay 12 cents? All of the major companies who own, generate, and sell AI have had massive layoffs due to AI. And they're restructuring their company. So they're not just firing low-level programmers. They are actually retraining or rehiring people to do higher-level things. So the big opportunity for them is to determine what areas could they deploy AI in to make money and to make the corporation better. So AI, compared to all other technologies, they have a much greater productivity benefit. There are going to be more job categories lost and more categories gained as a result. AI is a meta-technology. It's a technology that produces technology. And steam power is not one of those. Most technologies are not meta-technologies. And finally, Sam Altman said 2 weeks ago, and Jamie Dimon, who's the CEO of JP Morgan, the CEO of JP Morgan in New York City, yesterday said that AI may replace all human jobs. And I'll give you a chart on that as well. I think I'll skip this. So there's an economist at MIT, and he made the following really interesting observation, which I would like to believe. And so I've already told you that the lower level jobs go. So what are you going to do with these people that don't have high skills? What? So what he says is going to happen is these people with lower level skills will actually be able to use AI tools because the AI tools will augment their skills with the AI skills. So they may get a lower salary, just like they had before, but do much more powerful work. So the way he characterized it was, he thinks that AI may restore the middle class, which is the heart of the U.S. labor market. So that's encouraging, isn't it? Yes? Smiles? Smile? Sort of a smile. So there's a gold rush going on, and you've already heard a couple of other speakers today mention this, and the issue is that there are, the AI owners are like 10 American companies and 5 or 6 Chinese companies. Pretty much the rest of the world doesn't matter. Because once you've got a tool and a foundation model, nobody can take that from you unless they produce a better one. Oh, I should also mention chatbots. Every week a new chatbot comes out and it surpasses the past ones. Some Claude 3 came out 2 weeks ago, and Claude 3 beats ChatGPT by a long shot. And the rest of the world are essentially AI consumers. And there was an interesting study done about 2 months ago, where they interviewed 12,000 senior executives of companies in the United States. And 50% of those senior executives, they're not AI experts. Presumably they have someone advising them. But 50% said, if you haven't deployed AI in your corporation, and if you haven't adopted it and deployed it in critical areas of your organization, you are not going to be competitive. And that seems to me to be true. So there's an arms race. Microsoft, Google, and many others came out and made a claim about a year ago or so that we're going to put AI in every product and service we produce. And they also publish on the web their guidelines or ethics for how you use AI. So be really, really careful. But they're going to put it in every product. This doesn't go together very well. And as a matter of fact, when Google came out with Gemini, which is one of its chatbots, when it came out with Gemini at the end of 2023, it immediately violated all the principles that Google published. Namely, it gave race-based answers to questions. And the cost of solutions I already told, oh, so I told you the story about ChatGPT costing $100 million, 15,000 chips at $15,000 a chip. The new NVIDIA chip costs, that we don't know because they haven't disclosed it, somewhere between 30 and 40,000, but it is many, many times more powerful. And so if you're a wealthy company, you buy a lot of those chips, and then you get the money back because I sell it to you. But and none of the other companies can afford that kind of investment. Imagine using $30,000, $40,000 chips. We're talking money now. There are three major risk categories with AI, and I'm going to do this one very quickly because it's kind of complicated. It is similar to AlphaFold, which is you look at the 3D shape of a molecule in order to use it for drug design. So pharmaceutical companies go to a company in North Carolina called Collaboration Pharmaceuticals, and they have a product called Megacin. And Megacin produces it. They give the pharmaceutical company says, here are our functional requirements for the drug we want, and then Collaboration Pharmaceuticals can give them 20 or 30,000 molecules that fit that functional description, or they may give them smaller. I don't know how that works. I'm not a microbiologist. And of course, because they're drugs, they have to be non-toxic. So that's the way Megacin was designed. A Swiss company concerned about toxic chemicals, they came to them privately and said, oh, by the way, can you do toxic chemicals? So you may have heard about reinforcement learning. It pats you on the back if you did the right thing, and it punishes you if you do the bad thing. So they flipped the reinforcement learning to it praised them for getting toxic chemicals and punished them for getting non-toxic chemicals. 6 hours of computing produced 40,000 molecules that were highly toxic, half of which man knew about, the other half man didn't know about. Why am I giving you this example? There are many, many problems in the world that could be used very dangerously against human society, and toxic chemicals are one of them. And AI did this in 6 hours of computing. So that's one example. And of course, there are as many as there are bad actors have ideas. So that's the first risk scenario. The second risk scenario is, remember I said we can't be sure that the problem that the AI tool solves is the one we intended, nor do we know if the result it comes out with is correct or is safe to apply in practice. So we would like the results are consistent with positive human values. The alignment problem is, how can you prove that your AI is in line with positive human values? I'll give you a slide in a moment, which I hope will horrify you. Misinformation is giving the wrong facts. Disinformation is giving misleading information to convince the consumer of something that is completely false. And then deep fakes, copyright, censorship, you've heard of all that. And we know that in China, we heard the example from the professor from Oxford citing that China has this credit system that uses AI for image recognition and managing its people. Tomorrow I will describe what I call the problem. And the problem is, how the hell do you solve this domain problem using AI? First of all, you've got to define it as an AI problem, and then you've got to solve it, and you've got to prove to yourself that what you've solved corresponds to what you intended. And this is not easy. AlphaFold. I'll tell you this now. You may have been assuming all along, due to my naive presentation, that these AI tools are based on a single model. And that was the case maybe a decade ago, but now they use many, many models. And AlphaFold, that thing that does protein folding, it has 32 models in it. Oh, has everybody heard of hallucinations?
So hallucination is when an AI tool, oh damn, I shouldn't show this picture. Sorry. A hallucination is when you ask a question of an AI a chatbot or system, and it gives you factually incorrect answers, or it creates fictional information, or it's just weird, or it doesn't correspond to your question. And that sounds like a bad thing, so you'd like to shut that off. The answer is you don't want to shut that off, because remember I told you about pizzas? If I showed the convolutional neural network 10,000 pizzas, I would want it to recognize a pizza that was not in the training set. That's called generalization. Once it knows, it then generalizes and is able to recognize any pizza. That's the inherent power of AI. So hallucinations are a feature. It's a bad feature. I'm sorry. The thing that causes AI to hallucinate is the general power of the AI. This picture was generated, and almost anybody could generate it before guardrails stopped chatbots from doing this. But this is a picture of a bomb going off beside the Pentagon in Washington. And this was generated in May of 2022. It went on the web within a half an hour. You can say this to your friends when you go home. Within a half an hour, the New York Stock Exchange dropped $500 billion. It was recognized what was going on, and this was false, and it recovered the next day. It didn't recover that day, it recovered the next day. This is an example of a photograph, a simple photograph, that almost any of these convolutional neural network diagrams can produce for you. But now they have guardrails, don't do bombs, don't do toxic chemicals. So the impact can be really huge. How do you reduce the risk? Well, since we don't understand it, we can't use any sort of theory to prove it's right or wrong. So there are all kinds of engineering techniques that people have developed. I'll tell you about a few of those tomorrow. However, just going back to the previous talk by the professor from Oxford on ethics in AI, or ethics applied to AI, is these issues are not technical issues because we don't know how to solve them technically. They are social, moral, and political issues. And as he explained in detail, we have to rethink things in the past, things that in the past didn't seem so harmful, but now can be very harmful. Can AI destroy society? Yes. Megasin. Atomic bombs. I will quote later, I'll give it to you now. Henry Kissinger, the most senior statesman in the United States until he died a few years ago, he predicted that AI will bring the world towards nuclear war. And the way he described that is, if you have two powers, they both have AI, and they both use it militarily, and you're about to attack or be attacked by them, the escalation that in nuclear war takes weeks or days or weeks, will happen in seconds. So, and he knows about war. He conducted the Vietnam War. So he's not a good guy, but he knows about him. So is it probable? I mentioned nuclear power. I won't go over all the details. So the world since 1945 and accelerated in 1952 with a hydrogen bomb, which was 100 times more powerful. It was 1 billion tons of TNT. And they tested it because they wanted to know that they could protect America. I mean, that is awful. Anyway, the world has faced the problems before, so will it let AI kill the world? It's not my problem. Jeff Hinton, who I mentioned earlier, who contributed to in 1986 to the advances of AI, he was the chief, as well as being a professor at University of Toronto, he was the chief advisor to Google, and until he retired with a public statement that Google is not using AI responsibly, and he was very concerned about that. However, I do want to bring this quote of his to your attention. which is he is recognizing that the way humans have dealt with reasoning and knowledge and understanding is qualitatively changing as a consequence of AI. Why? I'll show you in a little bit, but we're automating it. Henry Kissinger, he gave a more direct quote, which is data science, reasoning will change society by redefining the basis of knowledge. And as we look at knowledge, we thought we knew what knowledge was. Turns out we don't. We don't have a really good definition of it. I mean, it's information that can actually be used in practice to remedy or solve a problem, something like that. But it becomes a deeper issue. Tim Berners-Lee, who invented the internet, he invented the web on top of the internet. He had a much more interesting and positive way to look at it. He said that in 35, by the way, the internet was invented 35 years ago, so he just recently gave a speech and saying in the next 35 years, what he expects will happen is everybody will have an AI agent that acts like a doctor or a lawyer or accountant does for you nowadays, and these agents will be completely trustworthy, privacy and all that stuff, he hopes, and they'll know absolutely everything about you because all of your knowledge will be under your control. Google won't have it, Apple won't have it, so that's the image he wants to create. But it's quite a reasonable image, I think, if you want to treat AI positively. So a survey of 3,000 AI experts from Stanford, Harvard, MIT, Oxford, Cambridge, these are authors of AI. They were asked in 2022 and then again in 2023 what they thought the impact of AI would be, and whatever they thought. And so in this case, will it gain human-level intelligence? And they said it'll gain 25% of human intelligence by 2040. And then in 2023, they were asked again, they said, no, it's not going to happen by 2040, it's going to happen by 2030. So the experts are seeing that this is a revolution that's just at its birth, and it's accelerating. I think I'll skip a couple of these. This you can't see anyway, but it gives the estimate by those experts of when a task or a job will be eliminated. And at the very bottom, it says all of low-level programming will be completely eliminated by 2025. And so this has been thought about a lot. There were still 5% of the people in both years that believed that AI could be used to harm the world, but the vast majority believed, more so in 2023 than in 2022, that it would either be neutral or good or very positive. And very positive is things like AlphaFold or recognizing cancer. So a paradigm shift is underway. What is a paradigm shift? A paradigm is a concept, and you use that concept to do reasoning and thinking and problem solving. A paradigm shift occurs when a new concept replaces the old one, and therefore new reasoning replaces the old reasoning, and it becomes a revolution when the change is profound. So you know that the scientific revolution took place over about 400 years, and the change was going back a long way from knowledge that came from God through the church to knowledge that came through empirical experimentation, and that empirical experimentation was refined in the 17th century for the scientific method. And the impact of science was a vast gain in intellectual reasoning and thinking and a much greater knowledge of the universe. The Industrial Revolution is even simpler. It replaced manpower at a human scale with automated power at industrial scale, and the consequence there was not just cheaper manufacturing and more goods, but it completely changed society. So the AI revolution is, the philosophy is knowledge discovered by, the concept that's being replaced is science. So science is knowledge discovered by manual empiricism at human scale. And in the 21st century, it is knowledge discovery by data science automated at massive scale. So, and the impacts, we don't know yet, but I've already shown you it's helped to solve cancer, helped to design drugs. It's saved millions of lives with the vaccines from Moderna, and that is just the beginning of all these things that are done. As you can imagine, every discipline in the world is looking at how they could use AI. At Harvard, I can tell you that every department, maybe not English or the humanities, although oh no, that's true, they are doing that as well, looking at patterns of speech in very ancient plays and modern plays. So every professor in Harvard is looking at how it can be applied to their discipline. And we had a day of the physical scientist, 2 days, and at the end there was a panel, and I asked, to what extent do the physical sciences require AI? And the answer was, if we don't use AI, we're going to be beaten by other people, and we're not going to get as many innovations. We have yet to discover the impact. Aha! Now, in order to go on this paradigm shift, first of all, you've got to accept the new idea. You've got to understand it. You've got to be able to use it for reasoning. And then you've got to be able to apply it. So science took about 200 years to do. Industrial Revolution maybe took 100 years to solve a lot of human labor problems and get it dispersed around the world. We don't know how long it's going to take here. Now, I've been telling you a very positive story with some risky outcomes. So every new technology apparently follows this path. And at the moment, we're at the peak of inflation of expectations at the moment. The stock market is way up. Individual companies that use AI, their value is way up. It's being deployed in many places positively. At the same time, a lot of AI startups are failing. And there are a lot of people that claim that it's not going to solve the world's problems. AI-based data science, this is the long expression of the philosophy, it uses computational analysis over data sets that are representative of the phenomenon you want to analyze. Meaning you've got to find the data for that phenomenon that has all the features that are necessary to determine it. So AI-based data science has an underlying philosophy. It has a problem-solving paradigm, which I will talk about tomorrow. And the answers you get from data science are not answers. They're insights that you then have to look at. And even those insights are probabilistic, uncertain, fragile, and they may be entirely dependent on the analytical method you use. Maybe you should have used another one. Or on the data that you use. Your data may not have been very good. So I'm going to do this quickly because I have a minute left, and that is that AI-based data science is vastly more powerful than science, bigger in scope, because in AI you can look at anything as long as there's data for it, an idea or a physical thing, but science looks only at physical phenomena. The scale, everything in science is done at human scale because it involves human concepts. In AI, we have 100 trillion parameter models. Complexity, I guess you can see that already. Flexibility, realism. Science, I believe, tries to provide a definitive answer to everything. Yes or no, this hypothesis is either true or false. In data science, we don't know. This might be an idea. I think the world is more like quantum physics than the physics before that. So I believe this is pretty close to the end. And oh, we got 54 seconds. So AI-based data science, we're at the beginning of a revolution where we're using a novel knowledge discovery paradigm that is data-centric. It has this massive power scope scale complexity that we've never seen before, and we haven't yet understood the extent of it. It will transform every data-rich job and task. We don't understand how it works, and we don't understand how to interpret the results. A lot of experience will tell you how to do that, and you have to use the insights. However, one interesting thing is using data science. Humans are the most are the chief power in using it. You've got to figure out how to solve the problem. So, thank you for listening. I'm sure I gave you a lot of questions. And if you have questions, please send me an email, and I'd be happy to answer them. Okay?